Okay, so next we have Mr. Youssef Kandil, Senior Data Scientist at Mendel.ai, presenting Bias, Explainability, and Accountability, the Data Scientist's Burden. As AI systems increasingly influence societal outcomes, Mr. Youssef will discuss the ethical and technical responsibilities of data scientists in building transparent, fair, and accountable systems. Please, I would like you all to welcome Mr. Youssef Kandil on stage.
Hello everyone. Just to introduce myself initially, my name is Youssef Kandil. I'm a senior data scientist at Mendel.ai. I also hold a master's of data science from RWTH Aachen. And it's going to be my absolute pleasure to give a talk today at DSC MENA 25 after attending last year as an attendee in DSC MENA 24 about today's topic, bias, explainability, and accountability, data scientist's burden. And why I settled a bit on a heavy title rather than a light-hearted title is that because with the AI hype these days, I believe there is a lot of rushing forward to carry out things with AI, but not realizing the impact of it. So let's start first by talking about good things. Everyday data scientist, even if you're not in the field, even if you're not a computer scientist or a mathematician, you probably know to some extent that data science affects your everyday life. You've heard the hype words, you've heard ML, you've heard AI, you've heard LLMs, agentic AI, all of that. So these are some examples that I think are used by all of us. You have content recommendations such as video and movie and TV series recommendations, audio such as music. You have YouTube videos as well. And you have product recommendations as well, such as frequently bought together. Since you have this cart, what other products might you buy as well? Something like maps predictions. If I can predict tomorrow's ETA at specific time, this is machine learning as well. And spam detection. We've all been through it. We saw a spam folder just being filled with emails and we don't understand how that's being realized, that this is because of the use of ML. So in multiple ways, across different years, data science has affected all of our lives in very positive ways. Then, if it works, then why worry? Because why would I be wasting my time and more importantly, the time of the audience here? Because everyone's happy with data science when it works, but when it fails to serve you and it actually damages you, this is when you get concerned with the consequences of data science. This was the first car crash by a Tesla car in 2018, which resulted in the death of a passenger, a tragic result. So, excuse me. Yeah. Just to provide more consequences into how irresponsible data science or not being focused on the bad comings of what data science could give. The first example was Apple issued credit cards, and the case I'm presenting here is a case from 2019, where David Heinemann, the creator of Ruby on Rails, mentioned that he got 20 times the limit of his wife. And he actually complained to Apple about it, and they just said that this is the algorithm. So while that model did not have gender, it actually learned the gender bias from other features inherently. Another case was healthcare risk assessment, where people of color were given the same risk score even though they were in far worse medical condition when compared to white people. And we're going to delve into that use case specifically. And hiring tools. Credit to Amazon on this, they actually carried out their due diligence to test their own model, and they found a bias against female applicants. So, going to the study Obermeyer 2019, what happened in this study is that this data set, there were given risk scores for patients, and the race was captured as a feature, being white, being a black person of color, and whatnot. And it was found that for the same risk score, black people would have a far worse medical condition. And the reason for that was not actually a medical condition reason, it was actually a cost. These risk scores were defined by cost. And there were racial disparities in the payment of treatments for black people in this case. And this is why it was found that had you changed had you changed the race of those people, they would have jumped for likelihood to receive treatment from 17.7% to 46.5%. This is a very major change. So there seems to be some kind of bias in this case, but it's important to distinguish what kind of bias. So you have two types of biases generally that you should be concerned about. There is statistical bias and societal bias. Statistical bias is that your model does not learn the data well. This is the job of a data scientist. You fine tune, you try to optimize your algorithm to learn the data better. This is what you can control as a data scientist or a machine learning engineer. The other kind, societal bias, is an issue with the data set or the models themselves not representing the world well. And in this case, the previous data set showed an issue of societal bias, where it was not representative of the risk scores given white patients and black patients. So to better interpret the results or better understand the results, we need to talk about ways how we can understand why a specific model gave these outputs. So we have two very relevant topics, interpretability and explainability. I'll just say the formal definitions, and then we're going to talk about them more. Interpretability is what's the model doing, and explainability, why did it do that for me? A very nice example that I can think of in terms of commercial or even lightweight machine learning models is decision trees. What you find behind me here is that you have the interpretability aspect of it and the explainability aspect of it. With a show of hands, can you please tell me what's more digestible by any end user? Explainability? Okay, thank you. What you see here under interpretability is the actual mathematical equations that help you derive a decision tree. You have entropy, you have information gain, and this is how you decide which route is used at the beginning. Why was it age, not weight? So it has to do with understanding the entropy within the data and trying to make an optimal decision tree as much as possible. I think the entire audience would agree with me that the left part under interpretability is not digestible by everyone. Whereas explainability, we all love visuals. You would understand from this slide, you just traverse a path very smoothly, and you'd understand whether you'd land at a low score or a high score. Interpretability is very important to know how your model works inherently, the feature importance of it. Whether there is collinearity between your features. You need to understand a model when you're building it. But when you're presenting a result to an end user, you'll find that explainability is a far easier branch to give to a customer or an end user in this case. This is a case of a very powerful machine learning model, just a 3-layer neural network. This isn't for a specific use case. This is a generic 3-layer neural network. This will definitely be far more powerful than a decision tree, but I think you'll find it very difficult to actually explain this to someone, because this requires mathematical derivations and backpropagation, which includes a lot of differentiation, to understand the weight of the features. An end user would find it very difficult to understand this. Now, okay, then what's the solution? We use a lot of complex machine learning models. We are solving problems that we were not able to solve years ago. What should be the solution? Should we just discard those complex models to promote explainability? Of course, the obvious answer is no. We should not let go of powerful machine learning models. And I'm not in any way discarding the impact of the important machine learning models that we have had, but we need to be more responsible in digesting those models. So there is a specific branch that's gotten a lot of hype as well in the previous years, which is Explainable AI. Explainable AI has multiple techniques so that when you have a very powerful black box model, you try to make the end users understand the result from your model. So the first one, Shapley values, is actually a very intuitive explanation once you understand this. What this does is that it tries to predict a feature say, for instance, the annual bonus of a specific person. HR wants you to build an annual predictor, an annual bonus predictor. So you'd have, for instance, an average annual bonus of 1,000 EGP. So if someone has a different prediction, there needs to be moving factors as to why, for instance, their annual bonus was 1,500. What SHAP values does, which is short for Shapley additive values, is that it shows each feature for a specific prediction. So this is a local explanation. This is not a global explanation. And for each feature, it shows the increase and decrease. So for an annual bonus, you might have, for instance, 30 years of experience as a bucket, increasing that annual bonus by 100 EGP. You might find that a PhD will increase another 200 EGP. And these additive values, as I said, are for a specific local explanation. These additive values for the features can change for other predictions. Another thing is LIME, locally interpretable model explanations. And this is also a local explanation, but a different way it does it is that it generates random samples around the point that you're trying to predict, and it tries to see the model performance across those generated samples, and it tries to train something called a surrogate model, a far simpler model on those generated data points and the original data point that you were trying to predict, but a surrogate model that would be easily explainable. And the third one is counterfactual explanations. I think this visual is quite explainable within its own self without me explaining it, but what counterfactual explanations does is that for a lot of machine learning models, you tend to have unwelcome outcomes. I got rejected from a loan. I got rejected from a cancer clinical trial. I was rejected for a job application. So my natural reaction as an end user would be, why didn't I get the positive outcome? And what counterfactual explanation does, and this is, I believe, is a nice visual for this, is that I got rejected in this case. What would have been better to make me accepted is to increase my income by either $10,000 or increase it by 5,000 and have one more year of credit history. What you're going to notice here is that two alternatives were given. Counterfactuals have three criteria that need to be met for them to be usable. It needs to be diverse, so you need to have flexibility to change things. It has to be feasible. You cannot ask someone to be younger of age because we can't turn back time. And they just have to be actionable. So in this case, I want to reflect on a specific dataset called the Compass dataset. Compass dataset was a dataset on the judicial system in the US. And what happened in this dataset is that after analysis, it was shown that white people and black people, in comparison, you'd find that while 23% of previously charged white people had a 23% of being re-evicted, 45% of black people had that same probability. So there was a heavy racial disparity in, if you're just a person of color, you would have had a far higher likelihood of being re-arrested again. Now, I know I said that a counterfactual has to be feasible, but if we remove that restriction, this is the counterfactual explanation that you would have gotten. Had this individual been white, the risk scores would have dropped. Another example is the adult income dataset. The adult income dataset is a dataset that has shown for multiple employees, whether they're in the bracket of making more than $50,000 or less than $50,000. The issue with this dataset is that it's highly imbalanced in gender. The amount of males is twice the amount of females, and within this dataset, the male population, 1 out of 3 is more than makes more than 50,000, whereas females, 1 out of 5 makes more than 50,000. So the counterfactual explanation in this case would have been as well, had this individual been male, their income would have increased. Now, this probes a more responsible approach towards data science. And this is why there is a consortium of leading Dutch research groups which establish responsible data science. And It has standards called fact. So let's talk about some facts. Fairness, data science needs to be without prejudice. We need to ensure that data science does not in any way harm anyone. Accuracy, I cannot have a model that's inaccurate for the sake of being fair as well. Confidentiality, everything that you do as a data science project should not breach the confidentiality of your own data points. And transparency, you need to be able to be transparent about your outputs. Yeah. So this begs, again, why this entire talk was called the data scientist's burden. Because you need to have, in addition to the exciting, interesting questions about your data, you need to have the responsible questions as well. How will your model be used? Because in the case of accepting or rejecting loans, this is a data point that, if predicted, you can sleep easy at night as a data scientist because you haven't interacted with the person. But if they're rejected unfairly from a loan, this is going to probably push them in a very different direction in life. Who benefits from your error margin? So if you have an error in your own machine learning model, who benefits from this? And always the business question is, what story is your data telling you? But no one asks, what story is your data not telling you? As I said again, data science is embedded in our lives. So it's not just enough to be technically accurate or correct. It's not enough to brag about machine learning metrics. Ethical awareness should not come as a plus. It should come as a necessity, a crucial component of your models. And whether we like it or not, your models do shape society. And for the next slide, I'm sure I could have landed on a lot of smart tech people who could have quoted to end this talk, but I honestly just landed on a video game quote, honestly. But I think it's relevant as data scientists for any cycle of bias that we might have propagated or we have the potential of propagating. The cycle ends here. We must be better than this. Thank you. These are the slide references, and these are my actual references, and I'm more than happy to take any questions. Please.
Thank you very much, Youssef. I have two questions. The first one is, so I think also that one of the main things you mentioned that we rush for applying AI, but we also may rush for applying complex algorithms and complex models in cases when much similar models can actually perform like fairly well. So my question to you is, how much would you approve to compromise for the sake of a more explainable model? If you have if you are comparing between several models and you have for your most important evaluation metric, they are pretty much doing fairly well, and one of them is more explainable than the others, but is not like the top performing model. Would you choose this one for the sake of explainability? And also the second one is, you mentioned the imbalance.
Yes.
Do you have a specific percentage of imbalance that you would not accept because it would cause more bias from your experience? And that's all from me. Thank you.
Thank you. I think these two are fantastic questions. Thank you for actually adding to the conversation. So the first question is how willing am I to sacrifice a very powerful, complex model? Or how would I evaluate that this model serves the purpose but is not explainable, whereas in contrast, another one? So this is a very personal preference, and I think some data scientists would agree with me as well. If you have a rule that already explains your data, you should be heading there, not to machine learning. For instance, if we're talking physics, speed times time is distance. If you build a machine learning model and you have the speed and time, you're going to have a very easy model that predicts distance. But you already have an equation, you already have a rule. So doesn't make sense to jump forward to a complex machine learning model to solve this problem right away. To answer the question, it's very important to put the actual use case in mind, Because in some use cases, you might prioritize recall, but not precision. You want to get all cases, such as rapid tests in terms of COVID-19. I want a cheap test that produces very fast results. And it doesn't have to be precise. But I just want all users, all positive patients to be detected. Whereas I'm not 100% precise, and I'm okay with that. So it depends on the use case. There are some models that are not GPT or not Llama or not DeepSeek or whatnot. Sometimes logistic regression is a very nice model to use. You have log odds. You're able to compare when a feature is different to another one, what's the impact of that. So if you have important metrics that you need to abide by, if you need to have an F1 score greater than 90, it goes back to you if you're able to build. My approach would be, your first approach should be explainable. You should not build a model that's not explainable by default. It's a similar concept to something in security engineering, non-intrusive security, where in software engineering, it means that when you introduce security to your system, it should not compromise your system in any way. I believe this is the same case with explainability and data science. Of course, there's going to be a trade-off, possibly using a simpler model, but if your explainable model is already performing with, I don't know, 95% F1 and the required is 90, then you're probably good. And the explanation techniques I showed are actually, they latched on a black box model. So it's easier to use a simpler model initially if it solves your issue, but should you use a black box model, you should opt for an explanation technique similar to those to keep the impact or the strength of those black box models, but at the same time, to be able to understand your outputs. And what was the second question? I apologize. The imbalance, yes. I can't, it would be extremely unfair to give you an answer right away as a standard, but I would say entropy is a very nice example in this in general. So the first thought that would come to mind, have a data set that's 50% females, 50% males, whatnot. But I would say that if you have a data set that's already inherently by nature different, something like a medical condition being more prevalent in males versus females, so long as you have a good enough representation of the minority class, I think that would be okay. Because this data set would reflect real life. The issue with the hiring algorithm output that I showed and everything is that it selectively chose specific participants. And this is why it was not representative. This is why I explained the societal bias part. When you have a data set or a model that might perform statistically well, but they don't represent the real world that we're in. So my approach, honestly, the simpler your solution can be, the better. Of course, you're going to need machine learning, very powerful machine learning models, and sometimes you might not even care about explainability. And this question to the audience, do you particularly care when on social media it detects that this face is Youssef Kandil? I know I don't. It's a complex model. It's probably built by something called CNNs, convolutional neural networks. The concept itself is understandable, but it's not particularly explainable to end users, but I really don't care how this picture was detected that I'm Youssef Kandil. I'm okay with this. But if it's a life-changing decision that's going to affect my life, then I do need to understand the result. Please.
Thank you. You talked about the difference between the accuracy and transparency in the data.
Yes.
When you talked about the difference between the males and females, black and
Yes.
white or Hispanic, you talked about the problem, you talked about the why it affects us. In your experience, what you ended with a very nice quote, by the way.
Thank you. Thank you.
How do you think, in your opinion, in your experience, can we end the cycle?
How can you what? I apologize.
We end the cycle. We end this now.
That you're aware more about the biases in the data rather than jumping into building a machine learning model. You should take the time to analytically evaluate these results. You can do something as shadow deployment techniques in software engineering. What shadow deployment means, for anyone who doesn't know, is that if you have a current process where you accept and reject loans, for instance, or accept or reject any applications of any sort, that's done manually. You keep the process as is, and you deploy a shadow system where you compare the results of both. So you need to, this is an amazing question, by the way, thank you. To break the cycle, you need to make a conscious, active effort. You need to be more analytical. You need to understand the impact of this on your users. And there are actually some algorithms that do handle bias. The decision trees, for instance, there is a bias enhancing decision tree, basically, that detects automatically what possible biases you might have in the data. And there are actions to be taken then. But to break this cycle, you need to understand and to actually admit that there is a cycle. We cannot have a model. Exactly, because in this current age, and let me just say it's an amazing age to be a data scientist in. The breakthroughs, they don't happen even half yearly, they happen by 2 to 3 weeks. A new model is out, it's extremely powerful, it already passed benchmarks from other models. So there is a lot of excitement even, especially in the younger generations, to jump to these models. But I think there is beauty in simplicity. There is beauty in simplicity if you have a model that already solves the issue and it's explainable, understandable, that's great. If you need the complex model, then you need to make an active effort in making the data set representative and to provide explanations for those black box models as well.
Thank you.
Thank you. Thank you. This is a great question. I think we have a question first in the back, and then we're going to come here. Please. I thought you were the one who had the question. Please.
I was just asking about like an advice from you for someone like I want to be like a data scientist, but I'm stuck somehow in the mathematics and statistics background of being a data scientist. It's like an endless mission. So in this case, what's your advice for something like that? Because a way or another, you have to jump to implement the model and deploy it. So what's the point to start like getting to the next level?
You're saying stop, and I think this is an important way of phrasing it. I'd say in as difficult as it is, and especially in university and first job and whatnot, enjoy this phase. Enjoy this phase of actually learning the inner mechanics of these things, because it's very difficult in those larger models, just jumping into them, to actually understand you're just going to use it basically as a user. There is a term called vibe coding. I don't know how many people actually know about vibe coding, but it's actually someone who doesn't code, just LLMing their ways into building software. And the issue with that is if you're not an already refined software developer, engineer, data scientist, data engineer, a lot of professions, you wouldn't know the issues. And there are multiple errors you can have, logical and syntactical. Syntactical is that your software doesn't work. That's actually good because you know that the system should not be deployed. The far worse issue is logical errors in such a case. 2 plus 2 as a calculator equals 5. It works, it gets you an output, but it can be wrong. And you're going to trust it because someone told you to trust this model. And someone else told them to trust this model. So you need to make an active effort in trying to learn the inner mechanics, knowing, for instance, which clustering techniques work for this use case, which clustering techniques don't work. So yeah, as difficult as it is, try to enjoy this phase of actually learning these things, because natural language processing existed before LLMs. Actual querying search engines existed before LLMs. We have one question.
Thank you.
Okay. Apologize, I can take the question in person, but thank you so much. Thank you so much for attending. It's been an absolute pleasure to be here. And if anyone has any questions, I'm more than happy to receive.
Wow, that was such a powerful discussion. Again, I would love to thank Mr. Youssef Kandil for his wonderful talk, and I hope you have all benefited from such powerful discussion. Last, we would like to wrap up with giving a certificate of recognition for Mr. Youssef, if you would love to come up on stage.